quantity is a property that can exist as a magnitude or multitude. Quantities can be compared in terms of more, less, or equal, or by assigning a numerical value in terms of a unit of measurement. Quantity is among the basic classes of things along with quality, substance, change, and relation. Being a fundamental term, quantity is used to refer to any type of quantitative properties or attributes of things. Some quantities are such by their inner nature, while others are functioning as states of things such as heavy and light, long and short, broad and narrow, small and great, or much and little. A small quantity is sometimes referred to as a quantulum. Two basic divisions of quantity, magnitude and multitude, imply the principal distinction between continuity and discontinuity. Under the names of multitude come what is discontinuous and discrete and divisible into indivisibles, all cases of collective nouns, army, fleet, flock, government, company, party, people, chorus, crowd, mess, and number. Under the names of magnitude come what is continuous and unified and divisible into divisibles, all cases of non-collective nouns, the universe, matter, mass, energy, liquid, material, animal, plant, tree. Along with analyzing its nature and classification, the issues of quantity involve such closely related topics as the relation of magnitudes and multitudes, dimensionality, equality, proportion, the measurements of quantities, the units of measurements, number and numbering systems, the types of numbers and their relations to each other as numerical ratios. Thus quantity is a property that exists in a range of magnitudes or multitudes. Mass, time, distance, heat, and angular separation are among the familiar examples of quantitative properties. Two magnitudes of a continuous quantity stand in relation to one another as a ratio, which is a real number. Background: in mathematics the concept of quantity is an ancient one extending back to the time of Aristotle and earlier. Aristotle regarded quantity as a fundamental ontological and scientific category. In Aristotle's ontology, quantity or quantum was classified into two different types, which he characterized as follows. Quantum means that which is divisible into two or more constituent parts, of which each is by nature a one and this. A quantum is a plurality if it is numerable, a magnitude if it is measurable. Plurality means that which is divisible potentially into non-continuous parts, magnitude that which is divisible into continuous parts. Of magnitude, that which is continuous in one dimension is length. In two breadth, in three depth. Of these, limited plurality is number, limited length is a line, breadth a surface, depth a solid. In his Elements, Euclid developed the theory of ratios of magnitudes without studying the nature of magnitudes, as Archimedes, but giving the following significant definitions: a magnitude is a part of a magnitude, the less of the greater, when it measures the greater. A ratio is a sort of relation in respect of size between two magnitudes of the same kind. For Aristotle and Euclid, relations were conceived as whole numbers. John Wallis later conceived of ratios of magnitudes as real numbers as reflected in the following: when a comparison in terms of ratio is made, the resultant ratio often, namely with the exception of the numerical genus itself, leaves the genus of quantities compared, and passes into the numerical genus, whatever the genus of quantities compared may have been. That is, the ratio of magnitudes of any quantity, whether volume, mass, heat and so on, is a number. Following this, Newton then defined number, and the relationship between quantity and number, in the following terms: by number we understand not so much a multitude of unities, as the abstracted ratio of any quantity to another quantity of the same kind, which we take for unity. Quantitative structure: continuous quantities possess a particular structure that was first explicitly characterized by paragraph LDE as a set of axioms that define such features as identities and relations between magnitudes. In science, quantitative structure is the subject of empirical investigation and cannot be assumed to exist a priori for any given property. The linear continuum represents the prototype of continuous quantitative structure as characterized by paragraph LDER. A fundamental feature of any type of quantity is that the relationships of equality or inequality can in principle be stated in comparisons between particular magnitudes, unlike quality, which is marked by likeness, similarity and difference, diversity. Another fundamental feature is additivity. Additivity may involve concatenation, such as adding two lengths A and B to obtain a third A plus B. Additivity is not, however, restricted to extensive quantities but may also entail relations between magnitudes that can be established through experiments that permit tests of hypothesized observable manifestations of the additive relations of magnitudes. Another feature is continuity, on which Michael says of length, as a type of quantitative attribute. What continuity means is that if any arbitrary length, A, is selected as a unit, then for every positive real number, R, there is a length B such that B equals R. Quantity in mathematics, magnitude and multitude, the two principal types of quantities, are further divided as mathematical and physical. In formal terms, quantities are their ratios, proportions, order and formal relationships of equality and inequality are studied by mathematics. The essential part of mathematical quantities consists of having a collection of variables, each assuming a set of values. These can be a set of a single quantity, referred to as a scalar when represented by real numbers, or have multiple quantities as do vectors and tensors, two kinds of geometric objects. The mathematical usage of a quantity can then be varied and so is situationally dependent. Quantities can be used as being infinitesimal, arguments of a function, variables in an expression, or probabilistic as in random and stochastic quantities. In mathematics, magnitudes and multitudes are also not only two distinct kinds of quantity but furthermore relatable to each other. Number theory covers the topics of the discrete quantities as numbers, number systems with their kinds and relations. Geometry studied the issues of spatial magnitudes, straight lines, curved lines, surfaces and solids, all with their respective measurements and relationships. Quantity in physical science, establishing quantitative structure and relationships between different quantities is the cornerstone of modern physical sciences. Physics is fundamentally a quantitative science. Its progress is chiefly achieved due to rendering the abstract qualities of material entities into physical quantities, by postulating that all material bodies marked by quantitative properties or physical dimensions are subject to some measurements and observations. Setting the units of measurement, physics covers such fundamental quantities as space and time, mass and force, temperature, energy, and quantum. A distinction has also been made between intensive quantity and extensive quantity as two types of quantitative property, state or relation. The magnitude of an intensive quantity does not depend on the size, or extent, of the object or system of which the quantity is a property, whereas magnitudes of an extensive quantity are additive for parts of an entity or subsystems. Thus, magnitude does depend on the extent of the entity or system in the case of extensive quantity. Examples of intensive quantities are density and pressure, while examples of extensive quantities are energy, volume and mass. Quantity in logic and semantics, in respect to quantity, propositions are grouped as universal and particular, applying to the whole subject or a part of the subject to be predicated. Accordingly, there are existential and universal quantifiers. In relation to the meaning of a construct, quantity involves two semantic dimensions, one extension or extent to intension measuring all the implications. Quantity in natural language, in human languages, including English, number is a syntactic category, along with person and gender. The quantity is expressed by identifiers, definite and indefinite, and quantifiers, definite and indefinite, as well as by three types of nouns: 1. Count unit nouns or countables. 2. Mass nouns, uncountables, referring to the indefinite, unidentified amounts. 3. Nouns of multitude. The word number unregistered trademark belongs to a noun of multitude standing either for a single entity or for the individuals making the whole. An amount in general is expressed by a special class of words called identifiers, indefinite and definite, and quantifiers, definite and indefinite. The amount may be expressed by singular form and plural from, ordinal numbers before a count noun singular, the demonstratives. Definite and indefinite numbers and measurements, or cardinal numbers before count nouns. The set of language quantifiers covers a few, a great number, many, several. A bit of, a little, less, a great deal of, much. All, plenty of, a lot of, enough, more, most, some, any, both, each either, neither, every, no. For the complex case of unidentified amounts, the parts and examples of a mass are indicated with respect to the following: a measure of a mass, a piece or part of a mass, or a shape of a container. Further examples: some further examples of quantities are 1.76 liters of milk, a continuous quantity, 2 euro or meters, where r is the length of a radius of a circle expressed in meters, also a continuous quantity, 1 apple, 2 apples, 3 apples, where the number is an integer representing the count of a denumerable collection of objects, 500 people. A couple conventionally refers to 2 objects, a few usually refers to an indefinite, but usually small, number greater than 2. Quite a few also refers to an indefinite, but surprisingly large number. Several refers to an indefinite, but usually small, number, usually indefinitely greater than a few. References